My name's John Cassessa. I'm an investment banker at Guggenheim Partners. I've been in the automobile business for more years than I care to remember. And I'm really pleased today to welcome you to this panel on the future of the car. And the title is Look Ma, No Hands. Feels like we're at a significant inflection point in the technology of the automobile. And we have a spectacular panel to explore this. The bios are in here, but I'll introduce Chris Gerdes from Stanford University, Raj Nair, head of product development, Ford Motor Company, Chris Urmson, head of the self-driving car program at Google, and Kevin Vincent from the National Department of Transportation agency NHTSA, which of course regulates automobile safety. I want to start with the video clip. So if you guys can put on that Nova clip, and maybe we can give you a little bit of grounding of what we're going to talk about that today, and that's number 11.
Okay, seeing is believing. Unfortunately, Chris seems to think that riding is believing, and he wants to put my life in the hands of Shelley's computer.
We're off.
Just like a big, expensive toy.
Okay, and so you're I'm not doing anything right now. This is not slowing down very much at the curb. No, we really don't have to. We just went off the road, dude. If you don't go up on the rumble strip, then you're slow. Any race car driver will tell you that. What a smart little car.
Shelley is constantly adjusting her position on the track. Her adjustments just aren't very smooth. But I guess smooth doesn't matter if your only priority is staying on the road.
Chris, stop me. You okay? Oh my God.
Fortunately, Chris can take over at any time.
So, Chris Gerdes, who's at Stanford University and was the man not driving in the driver's seat. Can you tell us a little bit about what Stanford's doing and what you guys think about is the future for the car?
Great. Well, in that clip, we were showing one of the projects we've worked on, which is to try to develop a car that has all of the characteristics of the very best human race car drivers. Now, there's certain things that humans don't do very well in terms of paying attention, being able to look all around us, that it's easy to replace with technology and make an improvement. And we've also been looking at what are the things that the best humans do extremely well, and can we program those into a car as well. So that's one example of my own research. At our automotive center, we really think it's an interesting opportunity for universities to come together around the issue of the future of the automobile. So every discipline really has something to say about this. The car touches so many aspects of people's life, whether it's legal aspects, product liability, whether it's healthcare and accident prevention. We've in fact even been working with philosophers on how do you program ethical rules into autonomous vehicles. So I think we see this really as changing transportation, changing personal mobility in a huge way that can have a lot of societal impact, and a great opportunity for different parts of the university to come together and people to have great conversations about this.
Now, you've been doing automated automobile research for 20 years. And I guess my impression is now the world is finally coming to you. Do you feel that there is an inflection point here with the evolution of technology, that the appliance that we know as the car today is going to change significantly because of these technologies?
Absolutely, yes. I guess I was a little early on this, maybe not a great quality in private equity, but it served me well in academia. So we...
It's good you chose academia.
Yeah, there we go. I made the right career choice here. But I do see things changing in terms of the level of interest. I think Google's announcement of their self-driving car project was sort of the shot heard around the world on this that really got a lot of people excited. And so I think the technology has advanced. Cars are becoming increasingly able to do this already. Any car that you buy right off the showroom floor has a lot of this capability today. And the belief is much higher than ever. So I think we're truly at an inflection point.
So maybe we should talk a little bit about today's state of the art and some of the technologies that you can find in a showroom today. And I was wondering, Raj, if you would tell us a little bit about what technologies are in Ford cars today and things that maybe surprise people. They haven't shopped for a car in a long time.
Sure. As Chris mentioned, a lot of the technologies that are enabling for our automated driving are in vehicles that are offered today. In the Ford Fusion that we have on the road right now, the steering system is fully electric, so capable of being controlled by the architecture. The brake systems are fully controlled by the electrical architecture and control logic in the vehicle. The transmission is capable of being shifted electronically. The throttle is electronic. The sensors that are in the vehicle, and maybe we should run the video at some point in time, but primarily we're using sensors in our automated research vehicles that are already on the Fusion. Ultrasonic sensors, radar sensors, cameras in the vehicle. So many of the hardware requirements that you need for fully automated driving are being deployed in the vehicles for features like adaptive cruise control, which is that step on the path towards automated driving, collision mitigation and active collision avoidance. So, it's always hard to predict when we're going to get to this full level of automation, but we're already on the path. And many of you are driving cars that are, to some extent, already automating part of your driving experience.
So maybe we should show that video clip 16, which talks a little bit about how those technologies move toward.
So this is our Ford Fusion hybrid. It's a research vehicle, very advanced vehicle that senses the world around it and will help our drivers avoid congestion, help our drivers avoid potential collisions, and help ultimately create a safer and a more efficient driving environment.
What we wanted was a research platform that lets us push the envelope of what is the technology, both the hardware and software, for highly automated and autonomous functionality. What's different about this car is that it can see what's around it 360 degrees all the time, out to a football field in length, all around the vehicle. Unlike a driver that can only look at one direction at a time and only concentrate on one thing at a time, this system can look all around the vehicle, have complete situational awareness, understand what's happening, and will be able to react to what's happening around it, or inform the driver so the driver can react to what's going on around it.
We really look at it as an extension of many of the technologies that we've got in our vehicles today. Things like park assistance, things like lane keep assist. With those building blocks in place, they provide us with the fundamental elements to develop highly automated and highly advanced driving features, but at the same time always keeping the driver in control, always keeping the driver in the loop, and ensuring that we've got a fully safe driving environment.
So you saw from that clip, the towers on top of the vehicle, those are laser imaging systems. And on one of the vehicles we had an omnidirectional camera, but that was, other than the computer control system, that was the only incremental sensors we added onto those vehicles. And so you saw the car, driving through our engineering complex. You saw 3 vehicles in a row. They were actually platooning, so they're communicating with each other. And
what does platooning mean exactly?
Well, platooning is an opportunity to reduce congestion by having the vehicles communicating with each other, being able to run as a platoon closer than you normally would, not being subject to one vehicle slowing down, another slowing down, an accordion effect. And so that's the opportunity for automated driving to not just help with safety, not just help with convenience, but also reduce congestion in some of these urban environments.
So I want to shift gears and ask Kevin. Kevin, what is NHTSA's, well, first of all, why don't you tell people a little bit about NHTSA's mandate, and then maybe a little bit about a recent announcement for vehicle-to-vehicle communication, which sort of relates to the platooning conversation.
Sure. Thanks. NHTSA is the National Highway Traffic Safety Administration, and safety is very much our mission. That's our entire job, is to ensure the safety of vehicles on the roadways in America. And the recent announcement you're talking about is the announcement that the agency made, the department made, within the last couple months, that we would move ahead on vehicle-to-vehicle communications, move ahead on the regulation that would require vehicle-to-vehicle communications across the fleet and all vehicles in America at some point in the future. And the long history there is, for 10 years, there's been dedicated spectrum for dedicated short-range communications, 5.9 gigahertz, which has been set aside for the possibility of safety communications between vehicles. And we have finally made the decision, which we announced earlier, that we would move ahead on regulation there. We've been studying it for years within the department, but we're ready to move ahead now. So it's still the beginning of the regulatory process. We're not ready to issue a regulation, immediately, but we are moving down that path. And it holds great promise because actually one of the slides you have is slide 3. It actually shows how it kind of fits in with.
Yeah, let's pull up slide 3.
Fits in with autonomous vehicles and automated vehicles. It's maybe hard to read here, but one of the elements on that shows that there is possibility of having vehicle-to-vehicle communications added in as one of the elements of autonomy, of full automation. And what that provides is the vehicles, by communicating to each other, you don't have a line of sight problem that you need if you're just relying solely upon sensors. So a blind intersection, for example, with a V2V system, you could have a signal coming from one car to the other car so they know don't run through that blind intersection, which the current sensor-based systems can't solve that problem. There's several other problems that can be solved by, primarily line of sight problems, that can be solved by V2V. But in addition, it's also a secondary way of providing, or maybe primary way, but it's an additional way of providing a safety message in addition to the line of sight communication that can come from the sensors. So we think there's a lot of promise for the ultimate idea of automation, but also as a standalone system of having V2V communications ensuring safety in vehicles.
So from the standpoint of the NHTSA and the United States government, the idea that the automobile is going to be connected to one another and maybe someday, be autonomous, that is something you view as a positive?
Absolutely. So right now we know, and so we study this, it's our job, that 90% of the problem with accidents is human error. And automation holds the promise of eliminating human error as the safety risk. There may be other risks associated with automation, and we, because safety is our mission, we would be evaluating that risk. But we know fundamentally right now, automation, whether you achieve full automation or just the incremental automation that comes from some of the things Raj is talking about that's already out there, forward collision avoidance and some of the new systems that are coming on, the building blocks, which actually shows in that slide too, that slide 3 when it was up there, the building blocks that will lead up to full automation. Even if we never get there, they're great improvements in safety, but the ultimate solution of a fully autonomous car holds a lot of promise for safety.
I noticed there's a private organization, the Insurance Institute for Highway Safety, and they also do crash test stuff, and I think they recently published some results on auto brake, which were very encouraging, basically saying, if this technology, you have a much reduced chance of getting in an accident. And I guess the extent that consumers start to understand that and crash test ratings and all, that will help adoption of these technologies.
Absolutely, and frankly, the tests that are going on right now, which we think are good things, testing in environments that are well thought out, and what Google's doing right now, what Ford's doing, what the other companies are doing, are putting some miles on the road, and eventually at some point you can add up all those miles and you realize those automated vehicles are performing more safely than humans do behind the wheel, and that makes a very good case for automation.
And just so NHTSA is you're testing right now, you're in a program to test thousands of vehicles, is that correct?
Well, we don't really have the resources to do testing. So what we do is we evaluate testing done by the various companies, and we are in discussions with everybody. We meet with Google regularly, and we meet with all the automakers regularly, talking about what they're doing on automation, talking about what they're doing at all levels of automation. I mean, right now we're very, very interested in the building blocks because they're short term. We think full automation is long term. It's not next year. I don't think anybody's claiming it's next year. But right now, next year, there are forward collision avoidance systems are coming out and across the board, and a lot of incremental steps are occurring real time.
And that's not just on really expensive cars now, right? We're seeing Fusions and high volume cars. So Chris, I want to ask you, what is Google? What's the search engine company doing in the car business?
Yeah, that was pretty much exactly the first question I asked when I got invited to go out to Google and kind of be part of the work on self-driving cars. It's a search engine company, maybe it's an advertising company, why? And what I got convinced was that it's really a technology company, right? An engineering company, and because of the vision from Larry and Sergey, and it's kind of in the culture of the company, it's to go and solve big, important problems. When you look at transportation today, it's amazing, right? You can pretty seamlessly get from anywhere to anywhere else in the world, but the cost of that is immense. When you look in the U.S. at the rate of fatality and injury, it's mind-blowing, right? It's for people between the age of 4 and 34, it's the leading cause of death. And NHTSA and the automotive companies have made amazing strides over the years, but there's still room to go. And then you look further beyond to the challenges that are coming forward with the baby boomer generation aging and eventually losing the privilege of driving, right? Providing those people mobility will be a big deal. And so at Google, we look at this and we say, this is really a computer science problem. It's taking the data coming in from the sensors, figuring out what it means, how to react to it, and then commanding the vehicle to drive. And so that's why we're working in the space.
And you, by background, are a roboticist. Is that
yeah,
correct?
That's what my PhD says. Yeah.
Okay, and the people working this at Google are cross-engineering disciplines to.
Absolutely. So when we started the program at Google, we were really building on a foundation that had been set up by the automotive companies and by lots of great research in the past before we kind of kicked it off. A number of us had been involved with these competitions that the Defense Department organized called the Grand Challenges, where we had robots racing across the desert and then eventually in kind of a mock urban environment. And so we were able to attract a few of those people like myself. And then we reached into Google to pull in some world-class software engineers and human factors researchers we found and pulled into the company, and a great many people that are involved in our safe test program. So Kevin talked about the fact we have our vehicles out in the public roads, and we don't just kind of set them out there and hope that it all works out well. We have a really good training program that we bring our test drivers in, we run them through, and then they're kind of the heart and the soul of the team out there understanding how the vehicles are behaving and bringing back that data for engineering teams to work on.
And how much of this have you done? How many miles or hours, or how do you measure how much time you've had on the road?
So we can give you a measure, but it's very imprecise, right? So we've done at this point about 700,000 miles of testing on public roads. The cars have we bring that data back, and we can then use that in our offline simulations. So while we may have physically driven 700,000 miles of roadways, we can play it back over and over again and kind of gain the learnings from that and make sure that when we make changes to our software that we didn't kind of break something accidentally, right? So we improve this one thing, everything else also still works well. So millions of miles in simulation.
Okay, and California lets you drive on public roads?
Yes, they do.
Yeah. Now, Raj, where are you doing all this testing? Are you on public roads yet, or is it mostly at the proving grounds, or how does Ford?
It's a combination of both. We're fortunate to have pretty large proving grounds, so we can set up a lot of scenarios, and without having to look for those type of scenarios on public roads, and set up increasingly complex scenarios. But also, we've done some on public roads, some of the vehicle-to-vehicle and vehicle infrastructure communication testing we're doing on public roads. We think we have the first documented case of an actual real accident that was avoided because of vehicle-to-vehicle communication. We're only running, a handful of cars out in Ann Arbor, and actually had one of the cars that was screened and was going to pull out, and happened to be another car that was on the network, and the two cars advised each other that they were there. Warning came off, driver stopped, and the other vehicle went by. So even with a handful of cars in a fairly large city like Ann Arbor, we've already seen a benefit.
And is that V2V technology that Kevin's talked about?
It
that's
is.
In those cars?
It is one of the studies that NHTSA has been participating in, and we as one of the manufacturers participating in that study, just to see the likelihood and what the interactions are going to be like, both in vehicle-to-vehicle and vehicle infrastructure communication.
So I'd like to take a poll. We've got a lot more to talk about, but in the audience, who thinks they'd like a car that would drive itself? Well, that's really amazing. So why don't we? Yeah. Why don't we put up slide 4? This is a survey done by Cisco, and it's I guess they asked people if they would trust driverless cars, and it says globally it's 57%. In the U.S. it looks about 60%. It is astonishing. It seems like people generally think it's a good idea, and maybe they're used to, maybe people are very adaptable to new technology. And in terms of just the audience again, do you think you'd like it because of safety? Show of hands, safety? Convenience, you can do other things in the car with limits, right? I'll stop there. So have you've done research like this at Ford too, right? And you've asked done surveys and asked people about this, and what did they tell you?
Well, I think it reflected, what the audience showed here. A large number of people being interested because of the convenience. And as much as, particularly us in the industry really enjoy the driving experience, we recognize a fair percentage of it is fairly monotonous, whether it's highway or stop-and-go traffic. And being able to free up your time and have the vehicle handle that automatically it's a large driver. The safety aspects are very real, but can be somewhat intangible to the consumer and not maybe as well understood that this vehicle is actually going to be a much more reliable driver than they are. And so it's surprisingly variable by country as well, which is one of the things we're still trying to understand.
Yeah, can we put that slide up again? I was a little puzzled by this, and I don't know if it comports with your experience, but it says in Brazil there's enormous interest in this, and Japan almost no interest.
Yeah, and we're still trying to understand the cultural drivers for the differences in the country. Obviously, Japan, a very technically advanced country, yet very low trust in the technology.
And
right
in
now.
India, pedestrian safety is a huge problem, and that might have something to do with it because the infrastructure there is not great, and it's an enormous concern for policymakers there.
Yeah, pedestrian safety probably plays into it, probably even more is congestion and the level of traffic congestion in the urban environments in India.
Do you contemplate on these cars that you can set it to drive a certain way? You're a race car driver, right? It might be a little boring for you if you're sitting in a self-driven vehicle. Could you set it on aggressive and be like that Audi? Maybe you haven't thought of that marketing idea yet.
There could be a sports setting or a comfort setting. But yeah, there's going to be some tunables in this. There's going to be some very simple things like, we have the technology right now that can recognize traffic signs and cross-check that versus its map data as to what the speed limit is. And, you can theoretically set that to, I'll always want to drive 8 miles an hour above the speed limit, and the vehicle could theoretically do that.
Yeah, you won't.
And hopefully you're not connected to the infrastructure, so you're communicating that you're driving 8 miles above the speed limit, but yeah.
Chris Gerdes, Stanford works with lots of companies, and in your view, is this an industry-wide phenomenon, or all the automakers, all the suppliers on this? Is there a certain, and do you perceive any consensus that this is sort of an inevitable march of technology with the automobile, that it's just going to keep getting smarter and maybe ultimately autonomous?
Well, we have 27 companies that are members of our Center for Automotive Research at Stanford, and these include major automotive OEMs, but also companies like Intel and Texas Instruments, a lot of companies that have explored automation in other fields like Komatsu, for instance, which has done automated mining trucks. We also have Enterprise Rental Car, wondering what this will do to the rental car business, and companies like State Farm and Allstate Insurance. So it's really fascinating for us to bring all of these companies together on campus for some discussions about what might the future hold and what might need to change. The discussions are fascinating, but I don't think I hear anybody saying it's not going to happen. There really is very little discussion of, well, maybe none of this will turn out to be true. I think the belief, and of course, obviously, there's some self-selection in this, but the belief among all the companies that are working with us is that this is an inevitable march, whether it's towards the end game of full automation or whether there's some blend of the human in there. Maybe there's a little discussion, but I think in the long term, all the companies we work with really do see that this ability to go from any point A to any point B is a possibility.
So Chris Urmson, one could argue that these technologies will sort of make the car like a giant robot. I'm not sure that that's a great term from a marketing standpoint, but in a way, that's really what's happening. If you can have a vacuum cleaner vacuum the floor, this is sort of taken to its extreme. It's just a very sophisticated robot. Did people, you think of it that way at all?
Not really, right? So as a pure technology, sure, right? The word robot is kind of fairly poorly defined, and it can mean anything from your toaster to, C-3PO. But I think what people are going to relate to is what the car can do for them, right? And how it allows them to, be safer. How when they eventually, they're going out to a show, they'll be able to pull up outside, hop out, and then have the thing go park itself, right? And get rid of that, that part of pain in their life and that congestion they would create hunting for parking. So, we don't really think of them as robots. We think of them as, self-driving cars.
And do you think at all about how, the owner's relationship to the car might change? I mean, that everybody talks about America's love affair with the cars, and Chris told me he still drives a manual transmission and all that.
Yeah.
What do you think about that, or is that not on your radar screen right now because you're just creating the technology?
So right now, we're kind of blessed to be in a position where we're kind of trying to create the technology and make that work. But when we daydream, you certainly think about it, right? And what's exciting is that when we get to the point that there is a car that can drive itself and kind of go wherever it wants to, you could imagine lots of different things happening, right? You could imagine people still buying them and having them at their house and kind of using it to move, mom to work and then dad to work and then the kids to school. Or you could imagine something where the cars are shared, right? And that you call the neighborhood car and it picks you up and takes you to work and then picks somebody else up and takes them to work. So there's a lot of possibilities out there. We'll see where it goes.
I thought maybe we'd talk a little bit about infrastructure. Kevin, right now, or not right now, but to sort of make V2V and V2I, vehicle to infrastructure communication possible, what do you think that will require in terms of technology, investment, timeline?
So we're doing a report on that. We're doing some studies on that right now. So we don't have all of the details of that finalized yet, and we haven't released it. We will be doing that shortly with some ideas along that line. There's two elements of that. There's a fundamental infrastructure which is needed to make V2V happen, which is essentially to ensure the security of the system. There has to be a way of, without going into all the details, because frankly I bungle the details a lot when I get into them, but you have to ensure this. There's some certificates that are issued, and you need a security infrastructure to ensure that you've got a fail-safe, essentially, sort of security system for it, and that will require a infrastructure investment for that. V2I, by definition, involves rather extensive infrastructure. It's a question of how much infrastructure you roll out. You can maybe have infrastructure just in Ann Arbor, where we're right now doing the model deployment, which is the test that Roger was talking about there. And there's some other locations. The idea is you could have V2I would just run out, incrementally. Different places would install the infrastructure. So it holds great promise, but it's not something you just put it all across the country immediately. To make V2V happen, you would need to have the infrastructure necessary to issue all those security certificates.
So V2V, I mean, in my simple-minded way, you say 5.9 gigahertz like a wireless phone at home. I mean, you have to assure that it can't be hacked, intercepted, that there's data privacy. Isn't that the whole idea?
Yeah, there's a lot of privacy issues associated with it. Obviously, we have to address, and there'll be some public acceptance issues associated with privacy. We think it's a system that frankly doesn't raise a lot of privacy concerns, unlike driving around with your iPhone in your pocket, or right now the technology embedded in most cars. There's more privacy concerns there, but this is a different issue when there's government mandated infrastructure or government mandated technology versus people choose technology, and we understand that. So we will be evaluating the privacy concerns. We evaluate the security concerns. We think it's all more than feasible. We think it's quite doable. There's how you pay for the investment's a big issue. The government doesn't have a budget for this, so the government's not going to roll out the security infrastructure, but we think the auto industry writ large probably will be willing to do that. That's our hope, and will want to work with us to make V2V happen.
In a V2I, when we talk about, so let's take the model deployment in Ann Arbor. That's what I was referring to before, where I thought it involved 3,000 vehicles.
Something like that.
Yeah.
Sounds right.
So to install V2I there, it's sensors in the roadway, on the side of the roadway. What does it involve? Do you know?
V2I, basically what you would have is different infrastructure would have one gathering some information from the vehicles so you could communicate, like road conditions or traffic conditions back to other people further away, because it's short-range communications for V2V. So you have to be within, a few hundred yards of each vehicle in order to get that short-range communication. But you could have a communication to V2I, and then you could broadcast it, wider. But then you would also have part of V2I would be, for instance, the red light itself would tell you whether it's turned red or not. So you
Sure.
would know before you can even see that red light from the V to I communication going to the vehicle that the light's turned red. And you could have all sorts of other type communications coming from the infrastructure to provide a safety message.
And is it maybe we're sort of beyond what NHTSA is thinking about at the moment, but you know, this announcement's a signal to the world that you're behind it and you think it's constructive, and presumably, you know, this will require public-private partnerships to invest in this infrastructure, just like whether we're talking about toll roads or smart parking, things like that, same kind of stuff?
Yeah, it's definitely going to be the government working with industry, working with the public to make this happen, and with and local government. V2I is very much a local government issue because the road infrastructure is state and local government investments. So it's a matter of working with a lot of people, and again, the federal government is not, Congress has not put a budget in of any large amount. We have a small budget for what we're doing with ITS and other terminology we use for it. But in order to make this happen, it's going to require some private investment.
Maybe that's an interesting opportunity. So Raj, the cars that were in your video, they were sensing the road, right? You didn't. That road did not have any special infrastructure. That wasn't V2I. Those were cars that could sense around them. And I think Google too, right? Is really your cars are not dependent on that.
That's
right?
correct.
So why do you do that? I mean, why don't you say, geez, there's going to be government infrastructure, but you're creating right now vehicles that can do this without those sensors in the road? Is it just that technology is marching forward? You can do it, and you don't know how long the infrastructure will take?
Exactly. I mean, the technology is becoming more and more capable, and one of the goals really needs to be that it's going to be reasonably robust in a variety of conditions without vehicle-to-vehicle communication, vehicle infrastructure communication, both in terms of the robustness of it, the availability of it. And keep in mind, we're talking about an introduction of technology into a fleet that, on general is for the United States 11 years old.
So the average car in the U.S. now is 11 years old.
That's right. So even if we were to go 100% with the technology in any single year, right, you're only going to affect 10%. So you're still going to be driving with a vast majority of the fleet of the vehicles on the road that are not enabled with communication, that are not enabled with the automated features we're talking about. So it really needs to be robust to those type of conditions. So I think certainly V2V and V2I are enablers, but I don't see them as being required to get to increasing levels of automation in the driving experience.
So what I hear you saying is, in Ford's view, you're going to keep moving forward as quickly as you can with development of this technology, and take advantage of the infrastructure investment as it comes along, but also in a sense moving along independently as the technology is developed.
Yeah, absolutely, and because the benefits are very real, the benefits relative to driver convenience, and even more importantly, the benefits to safety without the V2V and V2I. So, and also, in our view, these building blocks are very valuable. So, however long the path to full automation may take, the individual building blocks and leading to increasing percentages of driving in an automated state are probably going to be more reliable and more safe than a human driver in those conditions. Now, how the regulatory environment and the litigation environment reacts to that and responds to that is certainly an aspect that we want to work closely with all our partners on. In this society, the tolerance for an individual human error is at a certain level. The tolerance for a machine error made on a higher volume is certainly at a different level.
So Chris, do you touch on these issues at all in your research, or is it purely engineering? I mean, there's been discussion about the issue of liability, of sort of acceptance of this technology, the idea that you're in an automated car, but the rest of the cars out there are still being piloted by human idiots. What is that? Did you talk about that at all in your work there?
Yeah, so this is something that we've actually been spending a lot of time with. I'm part of a group that the Daimler and Benz Foundation put together to look at the societal impact of automated driving. And this has been a fun opportunity to get engineers together with different disciplines. We also have a legal program on the legal aspects of automated driving at Stanford. So it really is great to have these communications open. So, from the legal side, the engineers can understand what the lawyer's concerns are. And a lot of that extends not only the technology, but what is the development process? What is the sort of process you can go through in developing this that will give you an argument later on that you had created a safe product? And can we put that into our students? And then working with folks in philosophy and psychology as well on this acceptance issue. How are people going to consider it? Is this just going to be an extension of their car that has gradually become smarter, or if it's cruising through the neighborhood unoccupied, is it viewed as a robot? How do people interact with it? Traffic is inherently social in many respects, and we have a certain expectation as pedestrians. We make eye contact with somebody who's driving, what that means. But what if the person in the driver's seat isn't driving, and we make eye contact with them? Does that mean something different? So I think there's all sorts of interesting aspects that go and connect engineering to social sciences, and I'm pretty fascinated by that.
And what have the philosophers said about acceptance, or is it really like acceptance of all kinds of other technologies? Or?
Well, so the philosophers have actually looked at what are the ethical implications, and if a car has to make some decision in the event of an emergency, what should it do? If it's my car, should it do everything to protect me? Should it avoid contact with pedestrians, even if that means property damage arising? How do you manage these trade-offs? Trade-offs that might not exist if all cars were automated, but as you put it, when you have to deal with people doing idiotic things, do you mete out justice and say, well, that was the person who caused it, they should get the most damage?
Right.
How do you deal with these things? And so what's really fascinating is we've found that the things the philosophers talk about, the structures that they talk about between deontological ethics and consequentialism, are actually things that we can program. So we can take these sort of ethical debates and turn them into programming debates. At the end of the day, nobody has the right answer. But at least we found it easy to communicate with each other. So at least we can now share on the engineering side in philosophical debates that have been raging for thousands of years.
And Raj, has this yet become a marketing discussion with your colleagues at Ford?
I think the level of acceptance can be, very hard to predict, and we're always reminded of our history. In the early days of motor racing, you typically had a driver and you had a riding mechanic. It was required because he'd often have to be oiling the valves while you were racing or adjusting the carburetor. But he was also looking at the surroundings and understanding where your competitors were. And when the machines got to a certain point of reliability and the carburetors got to a certain point of reliability, someone had the bright idea of getting rid of the riding mechanic, and he installed rear view mirrors in. And there was an outroar in the sport, going way, way back, and particularly by the riding mechanics, that would be, very unsafe. How would the driver know what was around him without someone looking around to tell him? That's a technology we now all take for granted. Of course, we can drive a vehicle alone, and as long as we have side mirrors and rear view mirrors, we're understanding of our environment. That's actually not true. You saw in the video how much more capable the vehicle is of understanding the full environment around it, more robust in many weather conditions than the human eye is right now.
There's no blind spot, right?
There is no blind spot. And so now the level of comfort, we still have people that have trouble trusting their adaptive cruise control. They just are not comfortable with it, so we have to provide a menu option that you can use regular cruise control if you don't trust our radar. So that adoption will take time, but as with many technologies, as people become more comfortable with it and new drivers enter the fleet and take it for granted, you'll see the acceptance of this technology and I think the real value being recognized by the consumer.
It could be a bit of a generational thing.
Yeah, a lot of our drivers are learning to drive on video games before they ever get in a vehicle. So their comfort with those type of technologies is higher than the many of us that started with manual transmissions.
So, Chris, in back to the realm of imagination, and one could conceive of a car where you don't have to sit where you sit now, and the seats can face each other, and you could have a conversation, right? Or you can eat, you can do all these kinds of things. I mean, that's all. It sounds like Jetson stuff, but totally 1964 World's Fair stuff, really.
Yeah.
Right.
No, I guess everything is new again, right? What's great is that there's kind of no lack of imagination, right? And as you said, 1964 World's Fair, there was vision for cars that would drive themselves, and that you could sit in them and play dominoes with your beautiful wife and children, and do whatever else you were doing. And I think it's what's exciting is we're now starting to get to the point where we'll have technology that will enable that, and it'll take time, because as folks have pointed out, there's going to be other people on the roads, and the vehicles will have to be safe around those, and so there's going to be physical limits to how you can put people in the car, because if somebody bumps into them, bad things can happen. But just in imagining the freedom you'll have, even if you're sat in a perfectly normal car, but you can now trust that you're going to get where you're going to go, and engage in all the things that people are engaging in today, but do so safely. That'll be a big deal.
So could you share with us a little bit of the reaction? You've had a lot of guests in your cars, and what's been the reaction? How do people typically react the first time they get in a car that drives itself? And does it change if they spent more time in it?
Oh, absolutely. It's really amazing to see, and gratifying as a technologist and kind of a proponent, right? Is we'll get people who just don't believe, right, that that technology just couldn't exist. You could never have a car drive itself, and you sit them in the car, and there's a lot of hand waving and excitement and craziness when one of our safety drivers takes their hands off the wheel, and then 5 minutes in they're like, "Is that it?" Right? And we don't do anywhere near the stuff that Chris does, because I think it's pretty hard to forget that you're in a self-driving car and that thing.
Actually, we get the same reaction, not necessarily with David, unfortunately, but it's amazing. On the second lap, people are kicking back, going, it's doing the same thing as the first.
Right.
No one's gotten sick for us yet.
No. And so that's exciting, right? Is that people are kind of starting to trust it, and yet, this is just like a normal car. We last year we announced that we were letting some of our engineers take the car home and use it to commute back and forward to work. And we had this one woman who lives about an hour and a half away from the office, and she commutes every day. And she told us, we did kind of an entry interview and an exit interview with her. She said, she doesn't cook, she'd really love to, she doesn't exercise, because by the time she gets home after this hour and a half drive, she's just wiped out from fighting traffic. And we heard after she had the car for a week, she didn't want to give it back. And she said, you know what, for the last week I cooked every day for my family, and I exercised every day, right? Because when I got home, I actually, I was relaxed, I was energized, right? And this was a car she still had to pay attention, right? But it was doing the driving and kind of fighting the traffic for her. And so when you think about that, that personal value, right? That what it's going to mean to people, right? On this very kind of soft emotional level, right? It's going to be exciting, and that's what I think will draw. We can talk about the statistics of safety, we can talk about the the societal value, but the individual value is going to be immense.
And Kevin, one could conceive of a future state in which older people who might quit driving can now get around,
Sure.
and presumably younger people. I don't know if we thought about how young we want people in a self-driving car.
And there's no question this offers all sorts of mobility advantages for the public. The advantages for the blind and people who can't drive themselves right now are huge. So in addition to the great safety benefits, there's lots of benefits here. Another mission for NHTSA is actually fuel economy. We haven't touched on that here, but there's
let's
actually
talk about that a little
huge, the platooning stuff that Raj talked about, which can be enabled by automation or sensor-based automation, or through V2V, or a combination of both. Offers great opportunities for solving fuel or increasing fuel economy, and just if you get a large number of vehicles out there that are automated, what you'll do to traffic jams is just tremendous. So there's huge benefits here for the public beyond safety. Safety is number one in our book. It may not be what drives public acceptance. It's
Right.
probably convenience and some other issues. I know just from my own sense, I drive to work. There's actually a bald eagle in my commute to work, and I see it about once a week. And I would far rather watch that bald eagle while I'm driving to work than drive.
Yeah.
You know, but I actually have to drive. You know, and it kind of it bothers me. Yeah. So, and so I can see there's a you know, great advantages to it, you know, we're fully supportive of it. We want to make sure it's done safely, but right now everybody who's participating in the realm is as interested in safety as we are. So, you know, one thing we want to make sure we don't do is stand in the way of this. We just want to work with industry to, the V2V part, which actually cannot happen without government input.
Absolutely.
So that's a piece that we're taking on ourselves. The rest of it can happen without government input, but you know, with our role as safety regulators, we want to make sure it's done safety and tout the safety benefits of the incremental steps, because we can mandate the incremental steps, and we may mandate, probably will be mandating as they get proven out. When forward collision avoidance becomes a proven technology, which is it's pretty much proven right now. Yeah. We could very well mandate that in all cars. We did that with the first incremental step, which is ESC, electronic stability control, is mandated in all vehicles, and that's fundamental automation.
And they start to add up.
They add
Stability
up.
control and forward collision warning, blind spot detection.
Yep.
And just on the fuel economy thing, Chris, maybe how does that work? Why is that good for fuel economy when you're platooning? We talked about a truck company last night. Why is that?
Yeah, so I have a former student, Josh Switkus, who has a company, Peloton Technologies, that is platooning heavy trucks. And the fuel savings there are really dramatic. You can get about 10% fuel savings in the rear truck, maybe up to around half of that or so in the front truck, depending upon distance. If you go really close, you can get even greater fuel savings than that. But the trucks are basically a large shape going down the road, and so if you can have the air displaced by the first truck and kind of go through the whole platoon, just like you'd see drafting in NASCAR races at Talladega or Daytona, you can get a huge amount of fuel savings. So he's got a system based around the same V2V technologies that Kevin was talking about. And that's a nice way to think about rolling it out on the truck fleets, because the big fleets replace their trucks on a 5-year cycle. So you introduce a system like that, and 5 years later, most of the trucks on the road have this technology and the capability to communicate. But it's an interesting thing. It also allows the drivers to kind of connect with each other. So in this system, there's a camera, so the following truck can see through the lead vehicle. There's radars, so you have forward collision warning and synchronized braking. So if the front truck sees an obstacle, the rear truck begins to brake immediately without waiting until seeing some distance change or something like that.
And that, of course, would be great for people in cars, too, to have safer trucks.
Right, and it's nice that all of this stuff is really available at a very low price point, because the radar and the cameras are standard automotive components, and V2V is coming. So that's the only new technology, but as we know, that's going to be mandated in the future as well.
So I want to put up one more slide, and then let's go to some questions. Slide 5, because we touched on this idea of costs, and these data. This is a personal cost per trip per mile, and on the left side is I guess today's vehicle, and on the right side is shared driverless vehicles, and basically I think it underscores that there are enormous savings here in fuel economy, accident avoidance. I think this would include congestion and time, and I guess it sort of gets at the idea that the 405 freeway someday will move at 50 miles an hour, right? In this scenario.
Yeah, I think the level of automation and how the 405 moves is a certain enabler. I think the aspect of shared vehicles is probably, an aspect of the business model that's even beyond automated driving. And that's going to be related to, what are the urban environments, the infrastructure, the increasing levels of congestion. In many of the emerging markets, a larger middle class getting to the disposable income point of being able to afford a vehicle, moving from two-wheel transportation to four-wheel transportation. And so I think those societal pressures are going to have an impact on the business model above and beyond the aspect of automated driving. You know, the aspect of not wanting to invest in a vehicle, not really wanting to deal with the monotony of traffic jams, being able to get into a vehicle using voice commands and tell it where you want to go and only pay for that usage, and then letting that vehicle go serve someone else. That model actually exists right now. It's called a taxi.
Yeah.
But we still see a high degree of desire for personal ownership of a vehicle. And whether it's automated or not, I think the emotional connection you're going to have with, you know, the second most expensive purchase you're likely to make is there's still something to be said for that. So certainly the business model will be changing in the future, but for a lot of reasons relative to automated driving, relative to connectivity, to the vehicle becoming just another device on the Internet of Things, relative to the pressures on fuel efficiency and greenhouse gases, relative to congestion, all of those are leading to, as you said, an inflection point in the industry that's going to be looking different in the next 20 years than it looks right now.
So let's take some questions from the audience. Right there, that gentleman right there. Do we have a microphone? And if you want to identify yourself, you can.
My name is Carl Harris. I work for a private equity firm in Southeast Asia. This may be a bit of an impertinent question, so please forgive me.
Take the microphone away from this man.
If you take that chart, that last chart, to its extreme, right? Basically what that's saying is you'll have a third as many vehicles on the road and people sharing them, and there'll be much higher asset utilization of those vehicles and all of that. Now, that can be catalyzed by open standards around sharing, around payments, around trust-based relationships with other people's vehicles and all of that, or that can be catalyzed by decisions that individual automakers make or choose not to make. And I just wondered what your posture on that was, and I wondered whether the government should in fact be doing more to encourage those open standards today.
So obviously we would prefer not to see a third less vehicles, but I think the realities of some of those models is already coming to fruition. So we're actively engaging on many experiments relative to vehicle sharing all over the world. And so, you know, I think rather than sticking our head in the sand on other business models and the risks that they present to our current business model, we're actively participating and see how we can contribute to those changes. I think on the regulatory aspect, and I'll let the regulator speak to the regulatory aspect. If you think about aspects of asset utilization, that's not necessarily what the regulators are interested in, but certainly aspects of safety and congestion are, and the standardization of those type of technologies and enabling infrastructure is certainly something that I think the regulators would be very interested in enabling. I'm not sure the different business models is necessarily their primary interest in that.
From a regulatory standpoint, we want to enable societal good, but we certainly don't want to constrain the American public. So, so you'll never see some regulations coming out which will, mandate models like that. But to the extent that you need to have any regulatory standards, et cetera, to achieve it, then it's a good thing to achieve. A lot of it's going to require local government regulation more than actually federal government issues that you're talking about there. And so that's going to matter community to community because we clearly have a very decentralized local governments in this country.
Please. There you go.
Thank you. How many jobs do you think will be eliminated as a result of this automation?
What's everybody's number? I don't know. I mean, is anybody thinking in those terms?
I don't think we put a context on that. I think for a long period of time, as we've discussed, this aspect of what we call driver in the loop on the path automation, I don't see elimination of too many.
Like taxi drivers, truck drivers?
Well, I mean, it's one of the most complex transport pieces of equipment we have in the world right now is the commercial airliner and a heavy degree of automation, but for foreseeable future, I anticipate we're still going to have pilots up in the cockpit. And so I would, again, we're talking in the extreme, when will we get to the 100% automated vehicle? Your guess is as good as mine, but in the near to medium term future, I think drivers and commercial drivers and taxi drivers and bus drivers will still be part of the equation.
Short term, I would say this is just fundamentally good for employment. Just any technological innovation is just, it's going to drive, it's good for the economy, it's good for employment. That's short term. Long term, I guess it's theoretical. It could eliminate driving jobs, but that's a long time, long term.
Hi, Joe Greener on Ford.us. We're a political group for the tech community. So putting aside exactly the timeline of when we're going to get to driverless vehicles, it seems that we will. Eric Garcetti was just talking about the massive amount of rail infrastructure investment that LA is making, which is really exciting that we're sort of on the bandwagon 20, 30 years late. But if you, the timeline for the Wilshire subway, for California high-speed rail, et cetera, are in the decades. And if driverless cars are coming in that similar kind of time frame, are we wasting massive amounts of money on rail infrastructure, which will be out of date right about when it's done?
It seems to me that intermodals, the whole idea that you can enable seamless integration of multiple types of transportation, I think that's the real opportunity here. I don't know, Chris, wouldn't you?
Yeah. So we're at a fairly early stage in the technology. We talk about this driverless future, and we're excited about it. We're pushing very hard towards it, but it's not done. And then the second is exactly what John was saying, that you can imagine even in a world with personal driverless cars that are moving around picking people up, you would still want to aggregate demand, right? So you would imagine that it's actually more efficient to have a bus line or a rail line where there's a lot of people on it, and then have personalized service that brings you to that. You go multimodal down the high traffic area, and then get your personalized trip at the end. So I actually think that there's an opportunity to really do this well in an intermodal way in the long term, but there's a lot of uncertainty, and if I'm making large kind of capital investments, I need facts and not hopes.
And there is there's always with mass transit the last mile problem. You get a lot of people to one place on a train or a bus, but how do you get them to where they need to go? And this maybe is a technology that addresses that problem.
There's some interesting pilot projects that are possible as well. I think there's great opportunity for that. And I know there's discussion at the Port of Long Beach as being an example for automation. Sweden is actually looking at certifying individual highways for doing increased testing of automated vehicles. So to look at individual highways and say, well, where are the things that are going to cause the vehicles to have trouble and to fix that. So I think there's actually a role for doing some of these pilot projects that could be a good government role to see. I think it would be hard to say, well, we can go immediately with automated highways as opposed to high-speed rail, but looking at individual routes and saying, well, what's possible could be very interesting.
One sort of transition safety issue, that is, if you, over some period of time, if you have a mix of driverless cars but driver cars, young drivers have a high accident rate, and as you gain experience, that accident rate generally comes down. But if you have kids now who come in and don't have to drive a lot, you're going to have a lot less experienced drivers out there on the road. How do you manage that transition? It seems like some seriously novice drivers out there than you do now if you aren't gaining that same experience. You see what I mean? Mm-hmm. I wonder if you've studied that, how you manage that transition period until, I guess, where everybody's driving or not driving.
Well, one thing about these technologies is you can almost envision graduated driving in the same way as you have graduated licensing. So if you have technologies deployed, they could actually start to give more and more control to inexperienced drivers as they demonstrate a level of competence. The sensors that we have on cars, the actuators, actually give a lot of information now about how well the driver is doing. So one of the things that we are looking at in the lab is what are the feedback opportunities to give drivers today the feedback from all of these signals as to what they could be doing better. So that's just one possibility that one could envision.
And if I could say that we think the human factors research on all levels of automation, starting right now with if you have automatic braking, do you get used to the car braking all the time, and when you're in another car you forget to put on the brakes. Fundamental issues like that are something we are actually studying, and they're in some ways the most interesting aspects of the technology is how does a human relate to the automation, and we are very interested in that. We're funding some of that research. I said before, we don't do any research, we don't do any testing, and it's not true we do fund research, but we don't have the fundamental testing abilities the companies are actually putting out the automation. But we are looking at the human aspects as a big part of our research agenda.
I think that'll be one of the big challenges on this path as we go to partial automation of keeping the driver in the loop when we need him in the loop and going back and forth between an automated mode and back to a manual mode, and particularly when it's an aspect of the system, for whatever environmental condition it gets in, needs to hand back over, and anticipating that need to hand back over with enough warning for the driver to get acclimated and understand what's going on in the environment and take control of the vehicle. So thinking through that human-machine interface and making sure drivers have a real understanding of the technology. When we introduced automated parking on the Focus, so you saw in the video that the Escape parking itself, that was doing so automated. We introduced really with just steering control. And unfortunately, we had some drivers that didn't realize that brake control was not included. And so, again, it's really important on the path automation that the driver's in the loop and understands the capability of the automation.
Hi there. I'm thinking about our commercial real estate infrastructure, very long-lived assets. You're going to be forcing a model of driverless cars onto cities that are not built for or were not intended for driverless cars. What does this do for our malls, our downtown areas, our suburban areas? Do those things change? Do they go away?
After Amazon gets done with them. What next?
So I think it'll actually cause them to blossom, right? So I know maybe I'm in the minority. I actively hate going to the mall, right? And it's not because I don't enjoy shopping. It's not my favorite thing to do, but I do it. It's trying to find a parking spot, right? I live in Mountain View, Northern California. It's a relatively small town, but trying to find a parking spot on Thursday night to go out for dinner with my wife and kids, means that we don't go there. Right, so a day where you don't have to deal with that congestion, right, is a great day, and I think it'll be a wonderful thing for small business, right, because people will be able to get dropped off at the restaurant, enjoy their time, have a drink or two, get a ride home safely, right. So I actually think it'll be a big deal, and then when you look at the amount of land that is kind of consumed with the facilities for parking and for vehicles, in the long term, you can imagine that turning back into mixed-use space or green space. Right, and so I think it's actually one of the biggest things that will have a positive impact of cities in the future.
Spot for 1 second. The date at which a consumer will be able to buy a driverless car.
What's your definition of driverless?
You guys define it each as you would like, but I mean it's been very theoretical, and it's an excellent. I think we're all looking forward to it, but I'm guessing there's some real divergence between each of you as to when you think that will actually happen, and I'm kind of interested to see what that is.
Chris?
So I don't know about buy, but I think use is interesting. So Sergey Brin, one of the founders of Google, said, I think it was in 2012, he said within 5 years. I have a 10-year-old son, which means I've got 6 years. So that's kind of the time frame that we're pushing towards, and we'll see what can be done. It won't come out until it's safe and it's able to operate safely on roads, but that's the kind of time frames we're working towards.
Yeah,
Can you beat them to market?
Can beat Google to
Can you-
market?
yeah.
I hope so. We've got the car to start with.
Yeah. Indeed.
No, I think that it's a good estimation, particularly this aspect of when will one be available in driving versus buying one. And so, to market
you know, we're thinking in the 25 time frame, you know, 20 to 25 time frame. But again, this is very spiky technology, and particularly the development of the, you know, capabilities at limit, the development of all the software algorithms that need to be done, all the things you naturally do when you drive a vehicle that we now need to code into software, and then the hardware reliability and getting it to a level that the robustness and reliability equals what's expected of hardware versus what's expected of humans. So there's more work to do, but it's happening very fast.
Maybe just to bring it around to the opening, this was maybe another good example of an inflection point, because I think since about 1939, people would always say this is 20 years in the future, and now you hear between 6 and 15, and I think that's a really good example of the fact that we're really seeing this horizon shrink, and I'm comfortable with that bracket. I've got nothing further to add on that.
Well, we are out of time. I really enjoyed it. Thank you for coming, and drive safely.